let us discuss, let us revise the concepts of discrete mathematics. In our discrete, we have 4 units, right? Math logic, combinatorics, graph theory, and set theory. In this truth table, take this question in propositional logic. Construct the truth table of the following compound proposition. What I can recommend you is, when you are doing the revision class, don't open your class notes. Don't open your class notes or any other thing. You just follow my instructions, and how I am giving the question, you also practice in the same way, then the class will be useful. Okay. Okay, take this question and try yourself first. Try to remember all propositional variables. And the given formula is negation of P and Q or not P implies not Q. Right? So this is the given one. Just revise all the truth definitions. PQ, P and Q, negation of P and Q, negation P, negation Q, negation P implies negation Q, and final formula is negation of P and Q or not P implies not Q. Right. And let us take the truth values here. So if I take both cases can be true, both can be false. Coming to the conjunction and, my dear, we can take and here. Negation of P and Q, negation to this formula, this will become as F T T T like this, and not P comes to FF T T, and not Q comes to FT FT. Not P implies not Q, not P implies not Q in the sense, I think in this third area this is false. In remaining cases it is true. And the negation of P and Q in the sense it is available in this fourth column, and this is available in this last but one column. If I take OR operation between them, so nowhere it comes to false. False or true, true or true, true or false, true or true. The last column of the truth table, it is always tautology, it never be false, so you can conclude like tautology. My dear, my objective is you should solve this question, and in this question if you have any doubt, sir, how do you got this column or something, you please express me. I will make you practice revision in that way. My dear, not only in this problem, not only in this tautology or something, in throughout discussion of discrete mathematics, when you are preparing, where you are really struggling, where you are feeling difficulty or something, I used just to say this, not P implies not Q. What is implication definition? If you have some formula like P implies Q, if P is true and Q is false, in that case only the result comes to false. This is the truth definition of implication. Here, in this not P implies not Q, you just see not P column here and not Q column here, and observe these two columns. When not P is true and not Q is false, in this area only not P implies not Q becomes false. In remaining cases, it can be true like. Okay, I hope you got it. So the conclusion is it's a tautology something like. Now what do you say about logical equivalence? Logical equivalence means let us take some P is one formula, P is one formula, Q is another formula. So for these two propositional formulas, I have constructed the truth table. When we constructed the truth table, what it happens, they are same in all possible cases. So if P is true, in that case Q is also true. If P is false, Q becomes false like that. Then we can say the two formulas are logically equivalent. P is identically equals to Q, right? And take this problem, which of the following is not a tautology? Try this question. Without opening your class notes, if you solve the problem, I have given both truth table approach and also what do you call logical approach. Try to solve in that manner. So when you take something like formula B, let me take formula B. Formula B says that negation of P implies Q, which implies not Q. Yeah, when you are solving this, you can construct the truth table and you can solve the question. So one method is you can take the truth table and you can solve the question. And you can also apply the logical approach. Logical approach in the sense, my dear, the given formula consists implication. So if the given formula is tautology, tautology means always true. Always true means no false case exists. So when it will be false, if I show that this area is true and this is false, yeah, when the first part is true, second part is false, if I show like this, then I can say it is something called not a tautology. Let us consider negation Q is false. I feel this consideration is easy. When negation Q is false, Q becomes true. When Q is true, negation P, P can be true or P can be false. Both cases exist. Let me analyze like this. Sir, this area, true implies false, true implies true, this is true. Or even false implies true is also true. So this area, whatever I am talking about, this one, this area is true. Negation to this one is, negation to true is, becomes false. Yes, if the formula, if not Q is false, then we cannot make this part as true, which means true implies false case does not exist. Right? True implies false case does not exist, which means the formula B is a tautology. It is always true. So it's a tautology, we can say. Next, coming to something like option D. What is option D? We have P implies Q and Q, which implies P. P implies Q and Q, which implies P, like this. Now let us consider P is false. If I take P is false, Q can be either true or false, and P is false here. Let me consider case by case. First case. Sir, when you are taking P is false, Q can be true. This is one possibility. When you are taking P is false, Q can also be false. Second possibility. Both possibilities I have taken. Now what can I get here? False implies true is true. True and true. This is true. This is true and here it is false, which means there is a false case. Yeah, there may be some true cases like this. This is false, this is false, the result is true like. My dear, there may be some true cases, but if I find only one false case, at least one false case, I can say that the given formula is not a tautology. Right? I can say that the given formula is not a tautology. That is the approach we can say. Right, some students said answer is something like B. My dear, I have shown B is a tautology. In similar way, I hope you can understand A and C options also, and you can confirm that D is not a tautology like this. Now here we have a question like this. There is a formula, propositional formula, and I want to say what is this formula. Either it is tautology or contradiction or contingency. Can you respond with definitions? What is a tautology? Tautology means the given formula is always true and it never be false. And contradiction means the given formula is always false, it never be true. And coming to contingency, it is mixed. It is neither tautology nor contradiction, then we can call it as contingency. Now the given formula, let us take the given formula. P or Q or negation P. Let me use properties here. P or Q or negation P can be write as negation P or Q. Yes, commutative law. P or negation P or Q. Both formulas consist or symbol. So you can remove the parenthesis here and you can assign the parenthesis here. And P or negation P is a tautology. Tautology or Q. Tautology or Q is nothing but tautology. Yes, just like a law of dominance, right? So by using the properties also we can find the solution and we can confirm that the answer is tautology. Or we can also say that we can also say the answer by using truth table also. Yes, I think you practiced this. Yeah, let us see this. The given formula is P and negation P or Q, right? So if you take distribution, so sir, when we are going to take distribution, here the symbol is or, na? This is and symbol. and this is OR symbol. So this is AND over OR. If you are using different logical operators, then we can take distributive property. Instead of different operators, if you have same operators, both are ANDs, both are ORs, then we can take what do you call associative property. Now here in this case, let me take distributive property P and negation P or P and Q. Outside of the bracket we have P and, that P and is distributed to both, not P and Q. P and negation P is just like a contradiction, false, or P and Q here. False or P and Q, the result is P and Q. Like this. Yes, the given formula is equivalent to P and Q. P and Q is correct. Yeah, my dear, try this question. Let P and Q be two propositions. Consider the two formulae in propositional logic. So S1, S2 both are there. We are asking about tautologies and which are neither tautologies. Yeah, let us see the first formula S1. Not P and P or Q. Which implies Q. Actually, the first antecedent part we can simplify this some level. Without simplifying also we can solve the question. The idea is, let us try to examine the case like when x is true, y is false, exist or not. Let us consider q is false here. When q is false, p can be true or p can be false. Both cases exist. P is false here. Let us take P is true, one possibility, and another possibility. When Q is false, P can be false also. P can be false also. If P is false, not P is going to be true. Then what do you say here? True or false, it is true and false. Finally, false and false, this become false. False implies false, this is true. And here also this area becomes false. False implies false, this is true. So the formula never be false, it is always true. So you can say S1 is a tautology. Whereas coming to S2, S2 just acts like converse to this. Q implies negation P and P or Q like this. So if you consider Q is true, yeah, P can be true or false. Let me consider P is also true here. If P is true, negation P is going to be false. Now what the result I got? Sir, Q is true here and false and something, result is false. I can find at least one case where antecedent is true, consequent is false. True implies false case exists here. There exists at least one false. I can say S2 is not a tautology. right? That is the approach. Okay, let us see. Coming to the first part, the given formula is P and Q, which implies R, and which implies P and Q implies Q implies R. My dear, here this formula appears something like this. This is just like X and this is Y. Yeah, it appears X implies Y. So, if X implies Y is a tautology, if the first statement is true, what it should be? When X is true, Y should not be false. When X is true, Y should not be false. So, that is the case we can get. Now, how to make this one as true and false? I think making this area false is only one case, when this is true and this is false. So, if both P and Q are true, and if Q is true, R is false, in this case, this is true and this is false, and I made Y part as false. When Y is false, what is X I want to check? Is it possible to make X true or not? Sir, if you take Y is false, in that situation, P is true here and Q is also true, and whereas coming to R is false. Yes, R is false. Now in this scenario, this is true, true implies false, so totally this is false. So when Y is false, X is also false, false implies false, that comes to true. So the formula, the given formula never be false, it is always true, so you can call it as tautology. Okay, and let me check the second option also. In option B, what they are saying, the antecedent part is logically equivalent to consequent part. So X is the same as Y, right? So I want to take either X or Y, and I just want to construct the truth table and I can verify both are equivalent or not. Instead of taking the truth table, we can also use the properties. So in X and Y, I feel Y is like a big formula. So take Y and try to simplify it. Either we get X or not, let me check. Sir, Y is, that means consequent is, in the given formula, the consequent of S is P and Q, which implies Q implies R. P and Q, which implies Q implies R. So, which is equivalent to, what do you say? P and Q here, Q implies R. We can use implication law. We have implication law, right? So, if we have P implies Q, by using implication law, or you can say conditional law, you can take it as negation P or Q, which means not Q or R, like this. Now coming to P and Q, what you can take? Now this is P, this is Q. P implies Q you can take, then not P or Q. Negation of P and Q, or not Q or R, like this. And which is equivalent to, what is negation of P and Q? Let us apply De Morgan's law. Negation of P and Q can be written as not P or not Q, or not Q or R, like this. And which is equivalent to, what do you say? Not P or not Q. My dear, all symbols are R symbols. Yeah, disjunction. You can simply apply associative property. Not P or not Q or not Q or R, like this. So here you can take associative like this, and which is equals to not P or not Q comes to not Q. Now let us take the parenthesis to these two things by observing the antecedent part. Now what we can get? Negation of P and Q or R. My dear, again it appears like implication law. If we have not P or Q, we can write as P implies Q. From RHS to LHS, let us write. So this comes to P and Q, which implies R. So this is nothing but our required antecedent, right? So in the antecedent part, we have P and Q, which implies R, which is same as this one. This is our antecedent. Yeah, you may get the doubt something like this. Sir, when we are taking option B is true, option B is true. In option B, what I am saying, antecedent part is logically equivalent to consequent part. X is equivalent to Y. Sir, if X is equivalent to Y, how X implies Y can be other things, sir? X implies Y is definitely tautology. Yes, no doubt. If option B is correct, if you examine option B first, you can also confirm option A is also correct. Got it here? So here P says that X belongs to the integers either 8, 9, 10, 11 or 12, like this. And Q is a composite number. Composite number means it is having more than two factors, right? So composite numbers, they starts from 4. 2 and 3 are prime numbers, na? 2, 3 prime numbers. 4, 6, 8, 9, 10, 12, so on, like this. Now what is R says? R says that X is a perfect square number. 1 square, 2 square, 3 square, 4 square, 5 square, like this. And the proposition S says that X is a prime number. X is a prime number in the sense what we can get prime numbers 2, 3, 5, 7, 11, 13, so on, like this. So this is the given data, and take the formula. What is formula given? The integer X is greater than or equals to 2, which can satisfy this formula. So the formula comes to negation of P implies Q and not R or not S. Not R or not S, like this. Now let us take some distribution here. Negation of P implies Q can be written as negation P or Q and this is negation of R or negation of S. Let's apply De Morgan's law, which is equivalent to negation to the first formula and become as R, and negation to the second formula, negation R or not S. Right? And here what we have, negation to this, negation of negation P and negation Q, or negation to this R and negation of negation S, that is S. Let us examine. I want some integer x. For that integer, P should be true, Q should not be true. What is that? What is P? P says that x can be either 8 or 9 or 10 or 11 or 12, something like. And Q should not be true, not Q, not Q. Not Q in the sense, Q says that it's a composite number. So 8 is here, 8 doesn't satisfy, 9 doesn't satisfy, 10 doesn't satisfy, even 12 also doesn't satisfy, but 11 can satisfy. When x is equals to 11, the proposition P is true and Q is false, right? So what do you say? P and not Q can be satisfied by the integer 11, or just like a union. R and S, what is R? R says that x is a perfect square number, and S says that x is a prime number. So my requirement is, I want integer, that integer has to make both R and S are true. That means the number should be perfect square number and also prime number. In perfect square numbers, there is no prime number at all. Their intersection is nothing, phi. So answer comes to, here I have R symbol, so 11 union nothing, the result is 11. The integer which can satisfy the both things comes to set of 11. 11 is correct answer, my dear. Which one of the following is not logically equivalent to the formula P by implies Q? Yes, here the given formula is P by implies Q. So the by implication definition says that it can be like P implies Q and Q implies P. P implies Q can be write as negation P or Q, and in the next step I can go for negation P or Q, and also Q implies P can be write as not Q or P. So what can I observe is, I can say this step is equivalent to option A and the previous step is equivalent to option B. My dear, if you distribute this, you can also get option D, right? If you distribute this, something like this and not Q, negation P or Q and not Q, right? Or negation P or Q and P, like this. Okay. So this is just like R over and, or you can say and over R, just to do from right side, and which is equivalent to negation P and negation Q, or Q and negation Q, Yes, and negation q is distributed to both the terms. Now coming to the next term, there is and p, this and p is going to be distributed. Negation p and p, q and p, like this. Now here this term comes to tautology, not tautology, contradiction, I think so. Q and negation q, it's a contradiction, always false. P and negation p is also false. Then what do you say? We know the formula, just like identity law, P or false, result P only. In similar way, so P or this is P or false, the result is P only, which means what we can get here, negation P and negation Q. Yeah, just like P or false, the result is P. Or here we have Q and P. Q and P, and this is equivalent to option DR. The given question, the formula P by implies Q can be equivalent to option A, B and D, which is not equivalent to option C. Yeah, you can also verify with truth values, that is also okay, correct. Now let us discuss the questions on first order logic also. Check the consistency of the following premises. Yes, premises are nothing but the given facts, right? So in the logical inference, we consider that statements are always true. So they given two premises here, P1, P2, and if you take conjunction of the premises, the conjunction of the premises is, it consists at least one true. Yeah, in one area they have to be true, then there results some conclusion. Yeah, the conjunction should be, their conjunction should be true in at least one case, in at least one case. It is not required like all possible cases. Yeah, just to see this, here what we have, the given premises P1 is P or Q and P2 is negation P, and let us consider the conjunction of the premises P1 and P2, and which is P1 and P2. P1 is P or Q and P2 means negation P, like this. Now in this scenario, if we take the conjunction of the premises, yes, P or Q required, P here, Q here, and also P or Q. Then we required negation P. Then we required P or Q and negation P. Okay, PQ, disjunction means if at least one true, the result can be true. If no true is available, then only P or Q can be false, just like a last case. negation P, negation to the P is now here we have PRQ and also not P, and we are taking conjunction between them. When you take the conjunction true and false, I think here it is false, it is false here it is true, and here it is false. Yes, my dear, when you observe the premises PRQ available here and negation P available here, if both are true, the result is going to be true. That means the conjunction of the premises consists at least one true. If it is true at least one time, that is enough. It can lead to some conclusion, isn't it? In our first order logic, when you are saying there is a chance that PRQ can be true and negation P can be true means the result comes to true, which means it is going to be consistent. What is the exact meaning? In case of first order logic, you should understand something like this. Let us suppose P is a statement, the statement represents the faculty solves the problem, and Q is a statement that the student solves the given problem. What is PRQ says? P alone can be true, Q alone can be true, both PRQ can also be true. Maybe the teacher can solve the problem, or the student can solve the problem, or both can solve the problem also. But in the next statement, I have given that negation P. Negation P is also true, which means that faculty solves the problem, the statement is going to be false. Negation P is true, P is false. So faculty does not solve the question. If the faculty does not solve the question, then student has to solve the question. There is no other alternative to the student. If the faculty does not solve the problem, then student has to be. Otherwise, the statement PRQ cannot be true. Am I right, my dear? P is a proposition. The statement represents something like father yearns for the family. Father yearns for the family. And Q is a statement that mother yearns for the family. Yes, what is my statement says? What is PRQ says? Father yearns for the family, or mother yearns for the family, or sometimes both are like working employees, both can work for the family, no problem. Both are breadwinners to the family. And next, coming to negation P. Negation P in the sense, father does not earning. If the father is not earning, then what should be? Mother has to earn for the family. Otherwise, the statement PRQ cannot be true. That is the point I am saying here. When the statement PRQ is true, negation P is true, if there is a chance that if all given premises are true, P1 is true and P2 is true and P3 is true and so on and Pn is true. If the conjunction of the premises is true, there is some conclusion is possible. The conclusion is in the last example Q. Some conclusion is possible. You should understand the first order statement in that way. Then you can understand the first order logic application even in artificial intelligence also. Or if you are simply thinking like true or false, that is not the right way. Coming to GATE exam, they don't ask simply one question like this. They don't ask this much simple question. They can give the options like this. They can give 4 options and they can ask you in which of the following set of premises are consistent, which are not consistent like this. Okay. And if I go with option A, P implies Q, P implies R. Q implies not R. Q implies not R, comma P like this. My dear, they given 4 premises and they are asking the question which of the following premises are not inconsistent. Right? Here we have 4 premises. P1, P2, P3 and P4. Actually, we have to construct the truth table and we have to confirm P1 and P2 and P3 and P4. The conjunction of the premises can consist at least to one true case. But here, what I notice is, in the last small example, if there is a possibility that if the first premises is true, the second premises is true, then only the result can be true. From this small observation, I want to prepare the shortcut like this. Sir, the requirement is, in your truth table, if you find something like this is true, this is true, this is true, and also this is true. If you find this case, then only you can reach your goal. Okay. So P1, P2, P3, P4, let me start with simple atomic premises. P4 is true. Why? Because if I start from any side, no problem, but at the end of the process, I required P4 should also be true. So instead of taking the complicated thing, why don't you take the simple one first? P is true here. If P is true, and here also P is true, and here also P is true. If P is true, I think Q cannot be false. Q cannot be false. Now coming to R. My dear, here there are two possibilities. R can be true or R can be false. If you thought R is false and negation R is going to be true, or if you thought like R is true, then negation R is going to be false. My dear, if the premises P2 is true, P3 can be false. If P3 is true, P2 can be false. What I am saying, you cannot make all premises simultaneously true. You taken P4 true, agree, P1 true, I agree with this, and P2 also you successfully made true, but what happens to P3? It becomes false. Either P3 becomes false or P2 becomes false, that thing I don't worry. What I can say is, you cannot make all these 4 statements as true. Somewhere it is false or here false or here false. So true and true and true and false and something is always false. My dear, you are trying to check one case, the given set of premises is true in at least one possible situation, but that will never happen because the given set of premises are not consistent. Right, this is the approach of finding the consistency of the premises. I tried option A. Can you try remaining options B, C, D? Yeah, first take this and later do this B, C, D also. So I hope you take an option A. In the question they are asking not inconsistent means consistent. I tried option A I got it is not inconsistent. You respond with A is not our required answer. So you respond with B, C, D. What happens to option B? Option B is either R or M, not R or S, not M, not S. Yeah. Let us take not S is true, then not M is also true. Let us consider the two things. If not M is true, M is going to be false. If M is false, or false not allowed, R must be true. If R is true, not R is going to be false. S is already true, then not S is false. My dear, this area becomes false. These may be trues. But if one thing is false, I can say the result is false, which means it is not consistent. And coming to option C, P implies Q, Q implies R. P implies Q, Q implies R. Not R or yes. Not R or yes. Not P implies not yes. Not P implies not yes. And also not yes we have. Now let us take the atomic premises P is true. Here also not yes. Yeah, when not yes is true, yes becomes false. If yes is false, then not R must be true. If not R is true, then R should be false. If R is false, Q must be false. If Q false, P can be true or false. Till now there is no impact on P. Yes, if P is true here, here negation P is going to be false. Yes, we made successfully all given set of premises as true. This is true. This is true. This is true. This is true. And also this is true. Yeah, we have taken all 5 premises simultaneously true. There exists at least one true case. I am not saying it is always true. There exists at least one true case. That is enough to say that the given set of premises are consistent. My dear, in similar way, if you go to option D, what is D says? Q implies P, not R. Q implies P, not R. P implies yes. P implies yes. Q or R. Q or R, like this. Let us take like a simple premises first. Not R is true. If not R is true, R is false. Then Q has to be true. If Q is true, P has to be true. If P is true, yes should not be false. There is no impact on yes till now. Yes, we made it. This is true. This is true. This is true. This is true. All 4 premises are true. Then their conjunction is also true. My dear, there exists at least one true case. So I can conclude the answer. This is also consistent. Now coming to the question, which of the following are not inconsistent means consistent, option C and option D both are consistent like this. Got it here?